Imagine a young Isaac Newton, sitting beneath an apple tree, immersed in his own thoughts about the mysteries of the universe. Suddenly, an apple falls from the tree, and like a bolt of lightning, the idea of gravity is born in his mind. This seemingly simple event led to Newton formulating the concept of universal gravitation, which would revolutionize our understanding of the cosmos. But what if there was more to this story than just the laws of motion and gravity? What if Newton's secret life of alchemy and esoteric beliefs played a crucial role in his revolutionary ideas? Join us as we uncover the hidden depths of Newton's world and explore how his unorthodox pursuits may have been the key to unlocking his unparalleled genius. As Newton's curiosity expanded beyond the apple tree, he embarked on a journey that would change the course of science forever. His groundbreaking work, Philosophiae Naturalis Principia Mathematica, published in 1687, laid the foundation for classical physics and explained the laws that govern the motion of objects. Newton's three laws of motion provided the framework for understanding the relationship between an object's mass, its acceleration, and the forces acting upon it. These laws, applied to celestial bodies as well as objects on Earth, allowed humans to unlock the secrets of the solar system and predict the behavior of planets, moons, and comets with astonishing accuracy. In addition to these laws, Newton's law of universal gravitation explained the force that keeps us anchored to the Earth and the planets orbiting the Sun. This revolutionary concept shattered the long-held belief that celestial bodies followed different laws than those on our planet, revealing a unified nature of the cosmos. Newton's work in optics, particularly his discovery of the composition of white light and the invention of the reflecting telescope, transformed our perception of the world around us. His pioneering insights enabled the development of more advanced telescopes, which led to the discovery of new celestial bodies and the exploration of the vastness of the universe. But beyond these monumental contributions to science, Newton's relentless pursuit of knowledge ventured into realms far beyond the public eye, hinting at a secret life driven by an insatiable thirst for understanding the deepest mysteries of existence. Newton's insatiable curiosity and unyielding dedication to knowledge set him apart from his contemporaries, pushing him to explore hidden realms far beyond his publicly known scientific achievements. His unquenchable thirst for understanding encompassed not only the physical laws governing the universe but also the metaphysical aspects of reality. As a deeply religious individual, Newton fervently sought to uncover the divine design behind the workings of the cosmos, often blurring the lines between science and spirituality. This spiritual quest led him to delve into the mysterious and arcane world of alchemy, an ancient practice that sought to transform base metals into gold and unlock the secrets of immortality. For Newton, alchemy was more than just an obscure pursuit, it was a means to unravel the hidden principles that govern the universe and a path to enlightenment. His dedication to the study of alchemy was so fervent that he spent countless hours laboring over cryptic texts, experimenting with perilous materials, and documenting his findings in a secret code, known only to him. These secretive endeavors, hidden from the public eye, nurtured a side of Newton's genius that was as captivating as it was enigmatic, revealing a man driven by an unrelenting passion to decode the mysteries of existence. Born in 1642, in the small hamlet of Woolsthorpe, England, Isaac Newton's early years were marked by struggle and hardship. His father passed away before he was born, leaving him under the care of his strong-willed mother, who later remarried and left young Isaac with his grandparents. Despite these challenges, Newton displayed an innate curiosity and knack for problem-solving, often crafting complex contraptions and engineering ingenious solutions to everyday problems. During his time at the King's School in Grantham, Newton's intellectual prowess blossomed, but his social skills were lacking, as he was often the target of bullying and ridicule. This isolation further fueled his determination to learn, as he immersed himself in books, delving into the works of great thinkers like Descartes and Euclid. Fate intervened when his mother, now widowed once again, called him back to Woolsthorpe to manage the family estate. Newton, however, was not inclined towards a life of farming, and his family recognized his potential, ultimately supporting him in pursuing higher education at the prestigious University of Cambridge. At the age of 19, Isaac Newton arrived at Cambridge University, where he would spend the majority of his life engaged in the pursuit of knowledge. During these formative years, Cambridge was a hotbed of intellectual activity, with groundbreaking works in mathematics, physics, and philosophy shaping the academic landscape. Newton thrived in this environment, as his unquenchable thirst for understanding led him to explore multiple disciplines and develop his own unique ideas. In 1665, the Great Plague forced the closure of the university, but rather than stifling Newton's growth, this event allowed him the space to make some of his most significant discoveries. Working in seclusion at his family home in Woolsthorpe, Newton embarked on a period of intense study, which would later become known as his Annus Mirabilis or Miracle Year. During this time, he formulated the basis of his laws of motion and gravity, developed the foundations of calculus, and made significant strides in understanding the nature of light and color. Newton's return to Cambridge in 1667 marked the beginning of his ascent to academic prominence, as he was elected a Fellow of Trinity College and appointed to the prestigious Lucasian Chair of Mathematics. Over the next several years, Newton continued to build on his earlier discoveries, refining and expanding his theories, which would ultimately become the cornerstone of modern science. However, even as the world began to recognize his genius, few were aware of the clandestine pursuits that consumed much of his time and energy behind closed doors. In 1696, Newton's life took an unexpected turn when he was offered the position of Warden of the Royal Mint, a role that would require him to move to London and abandon his academic pursuits at Cambridge. Despite initial reservations, he accepted the position and quickly became immersed in the practical world of currency, finance, and politics. Newton's meticulous nature served him well in his new role, as he was tasked with overseeing a complete reformation of the mint during a period of rampant counterfeiting and economic turmoil. As warden, and later as master of the Royal Mint, Newton applied the same rigorous methodology and attention to detail that had characterized his scientific work, conducting thorough investigations, instigating new minting practices, and implementing measures to combat the counterfeiters. In one particularly infamous case, Newton personally pursued a notorious counterfeiter named William Chaloner, who had successfully evaded the authorities for years by producing remarkably convincing forgeries. Newton's tireless efforts and dogged determination eventually led to Chaloner's arrest, trial, and execution, showcasing the lengths to which Newton would go to uphold the integrity of the realm's currency. Surprisingly, despite his demanding role at the mint, Newton continued his scientific and alchemical studies in private, his fascination with the unknown persisting even amid the tumult of his professional life. Newton's life in London was marked by dichotomy, as the respected public figure merged with the enigmatic private scholar, forever shaping our understanding of the man who was both a celebrated scientist and a secretive alchemist. The creation of calculus was nothing short of a revolution in mathematics, enabling scientists and mathematicians to describe the world in new and powerful ways. Newton's development of calculus emerged from his attempts to understand the ever-changing nature of physical phenomena, such as the motion of celestial bodies or the behavior of fluids. Initially working in isolation at his family's farm during the Great Plague of 1665 to 1666, Newton began his groundbreaking work by laying the foundations for what he called the method of fluxions, which would later evolve into differential calculus. Newton's method of fluxions allowed him to describe the instantaneous rate of change of a quantity, a concept that would prove invaluable in both science and mathematics. Integral calculus, the other key component of the calculus toolkit, was also developed by Newton, enabling the calculation of areas and volumes of complex shapes and the determination of accumulated change. These two complementary branches of calculus, differential and integral, work together to provide a comprehensive framework for understanding the relationships between changing quantities, leading to profound insights and applications in natural sciences, engineering, economics, and more. It is important to note that the development of calculus was not solely the work of Newton. German mathematician Gottfried Wilhelm Leibniz independently devised a similar system around the same time, sparking a heated controversy over priority that persisted for centuries. Despite the rivalry, the combined efforts of Newton and Leibniz laid the groundwork for an astonishing range of mathematical and scientific breakthroughs, utterly transforming our understanding of the universe and the language we use to describe it. Newton's groundbreaking work on motion and gravity began with the simple observation that objects fall towards the Earth, an everyday phenomenon that would spark his revolutionary theories of motion. In his masterpiece, Principia Mathematica, published in 1687, Newton set forth his three laws of motion that completely transformed our understanding of how objects move and interact with one another. The first law of motion, also known as the law of inertia, states that an object will remain at rest or in uniform motion in a straight line unless acted upon by an external force. The second law establishes a relationship between an object's mass, the force acting upon it, and the resulting acceleration, providing a mathematical framework for predicting the behavior of moving objects. Newton's third law, the law of action and reaction, suggests that for every action, there is an equal and opposite reaction, explaining the balanced forces at play in countless phenomena throughout the universe. On top of his laws of motion, Newton also developed the law of universal gravitation, which posits that every particle of matter in the universe attracts every other particle with a force proportional to their masses and inversely proportional to the square of the distance between them. This law of universal gravitation, along with his laws of motion, allowed Newton to explain not only the apple falling from the tree but also the motions of planets, moons, and comets, providing a unified framework for understanding celestial mechanics. Newton's breakthroughs in motion and gravity marked a paradigm shift in the way humanity perceived the universe, enabling us to predict and explain the behavior of objects both on Earth and in the cosmos, and paving the way for future advances in physics, astronomy, and engineering. Newton's curiosity extended beyond motion and gravity, as he became deeply interested in the nature of light and color, setting the stage for his groundbreaking discoveries in optics. His experiments with prisms revealed that white light is a mixture of all colors, a finding that contradicted the prevailing belief that color was a property of objects themselves. Through his meticulous observations, Newton demonstrated that when a single beam of sunlight passes through a prism, it is separated into a spectrum of colors, similar to a rainbow. He also showed that these colors could be recombined to form white light again, proving that color is a property of light rather than objects, a revolutionary concept at the time. Newton's scientific inquiries extended to the behavior of light particles, leading him to develop the corpuscular theory, which posited that light is composed of tiny particles moving in straight lines. Although the corpuscular theory would later be replaced by the wave theory of light, Newton's work in optics laid the groundwork for future scientists to explore the nature of light and color further, paving the way for the development of modern optics and the understanding of electromagnetic radiation. Beyond his experiments with prisms, Newton also made important contributions to the design of telescopes, inventing the first reflecting telescope, known as the Newtonian telescope, which relied on mirrors instead of lenses to gather and focus light. The Newtonian telescope offered several advantages over traditional refracting telescopes, including reduced chromatic aberration and a more compact design, making it an essential tool for astronomers and advancing our ability to observe the cosmos. Delving into the secretive realm of alchemy, Newton's passion for this ancient art led him on a quest to understand the fundamental nature of matter and the cosmos. His alchemical pursuits were fueled by a desire to uncover the philosopher's stone, a legendary substance believed to possess the power to transmute base metals into gold and grant immortality. Though much of Newton's work in alchemy remained hidden during his lifetime, thousands of pages of his handwritten notes on the subject have since been discovered, revealing the depth of his obsession. Newton's alchemical studies were a labyrinth of complex symbols, cryptic codes, and esoteric language, reflecting the clandestine nature of alchemy during his time, when the practice was often linked to heresy and witchcraft. His experiments in alchemy involved the use of various substances, such as metals, minerals, and plant extracts, which he meticulously documented in his notes, providing a glimpse into his methodical and rigorous approach. One of Newton's most significant alchemical achievements was the discovery of the star Regulus, a metallic compound he believed to be a key ingredient in the production of the philosopher's stone. While the pursuit of the philosopher's stone ultimately proved elusive, Newton's alchemical experiments contributed to his understanding of chemistry and the natural world, informing his broader scientific inquiries. As we venture further into Newton's secret world, we uncover a brilliant mind driven not only by scientific curiosity but also by mystical pursuits, revealing a side of Newton rarely seen in the annals of history. In the 17th century, alchemy was often viewed with suspicion and fear, as it challenged religious orthodoxy and was associated with illicit activities. The Church considered alchemy a blasphemous attempt to replicate the divine power of creation, seeing it as a threat to the established religious order. Additionally, alchemists were sometimes accused of witchcraft and sorcery, as their experiments with mysterious substances and supposed magical properties were seen as dabbling in the supernatural. Many practitioners of alchemy were forced to operate in secret, concealing their work behind intricate codes and symbols to avoid persecution and maintain their personal safety. Alchemy's close association with the pursuit of wealth and immortality also attracted unscrupulous individuals and charlatans, further damaging its reputation and exacerbating fears about its intentions. Despite the dangers and stigma surrounding alchemy, some brave individuals, like Newton, saw past the misconceptions and recognized its potential to unlock the secrets of the natural world. Through their persistent pursuit of alchemical knowledge, these pioneers laid the foundations for modern chemistry, transforming alchemy from a shadowy, misunderstood art into a respected scientific discipline. Newton's alchemical manuscripts were filled with cryptic symbols and obscure references, a testament to the secretive nature of his pursuits. He often used anagrams and code words to conceal the true meaning of his experiments from those who might uncover his work, leaving a trail of puzzles for future generations to decipher. Newton's penchant for code and secrecy was not unusual among alchemists of his time, as they needed to protect their knowledge from being misused or misunderstood by the uninitiated. In his writings, Newton delved into a diverse range of alchemical practices, from the transmutation of metals to the quest for the philosopher's stone, a legendary substance believed to grant eternal life and turn base metals into gold. His careful study of ancient alchemical texts from both Eastern and Western traditions led him to believe that these mystical teachings contained hidden truths about the nature of matter and the universe. Newton's alchemical investigations were also heavily influenced by his interest in biblical prophecy and esoteric beliefs, as he sought to uncover the divine patterns and secrets hidden within the fabric of creation. By unraveling the intricate web of symbolism, allegory, and code in Newton's alchemical writings, we gain a unique insight into the mind of a genius who saw the pursuit of hidden knowledge as a key to unlocking the mysteries of nature and the divine. Newton's alchemical pursuits provided him with a unique perspective on the nature of matter, leading him to develop groundbreaking concepts in physics. For instance, his study of alchemical transmutations, where substances appeared to change their properties and identities, may have contributed to his understanding of the fundamental forces governing the behavior of matter. As he sought to uncover the hidden principles behind these transformations, Newton honed his experimental and analytical skills, which in turn enabled him to make significant strides in the realm of science. His interest in alchemy also led him to question the nature of time, as he sought to comprehend the processes by which materials aged and decayed. This inquiry into the nature of time would later play a crucial role in the development of his laws of motion, particularly his second law, which deals with the relationship between force, mass, and acceleration. Moreover, Newton's alchemical studies exposed him to the concept of action at a distance, a crucial element in his law of universal gravitation, which postulates that every particle in the universe attracts every other particle with a force proportional to their masses and inversely proportional to the square of the distance between them. The alchemical principle of as above, so below, which suggests a correspondence between the macrocosm and the microcosm, may have also influenced his belief in a unified, predictable, and ordered universe governed by the same natural laws. While the direct influence of alchemy on Newton's scientific achievements remains a matter of debate, it is undeniable that his passion for unraveling the mysteries of the universe was fueled, in part, by his fascination with the hidden knowledge and ancient wisdom found in alchemical texts. One intriguing possibility is that Newton's third law of motion, which states that for every action there is an equal and opposite reaction, could be linked to the alchemical concept of the unity of opposites. This principle, found in many alchemical texts, suggests that all things in the universe are connected through a balance of opposing forces, such as light and darkness or male and female. Newton's extensive knowledge of alchemy could have inspired him to search for similar patterns in the natural world, leading him to formulate this fundamental law of motion. Additionally, the laws of conservation of mass and energy, which are central to modern chemistry and physics, have roots in alchemical ideas. For example, the alchemical concept of solve et coagula - the dissolution and recombination of substances, shares similarities with the idea that matter cannot be created or destroyed, only transformed from one form to another. Newton may have drawn from this ancient wisdom when developing his understanding of the conservation of mass and energy, providing a foundation for future scientific breakthroughs in these fields. Another speculative connection lies in the parallels between Newton's concept of gravity and the alchemical idea of the anima mundi, or the world soul. The world soul is an all-pervading, divine force that unites all things in the universe and is responsible for the harmony and interconnectedness of all creation. Newton's concept of gravity as an invisible, universal force that holds the cosmos together could be seen as a secular interpretation of the anima mundi, reflecting his quest to decode the divine principles that govern the material world. While it is important to recognize that these connections are speculative in nature, they offer a fascinating glimpse into the possible ways in which Newton's secret obsession with alchemy and esoteric knowledge may have informed and enriched his groundbreaking scientific discoveries. As we probe deeper into the possibility that Newton's secret obsession with alchemy was the catalyst for his scientific genius, it is worth considering how this ancient and mysterious discipline may have shaped his worldview and nurtured his unparalleled creativity. Alchemy, rooted in the philosophical traditions of the ancient world, sought to unveil the hidden truths of the universe and the transcendent nature of reality. These ideas could have resonated with Newton, who was known for his relentless curiosity and quest for knowledge, as well as his deep, sometimes unorthodox, religious beliefs. His immersion into the world of alchemy, with its rich symbolism and emphasis on transformation, may have provided a fertile ground for developing his understanding of the fundamental forces that govern the natural world. Furthermore, some scholars suggest that Newton's alchemical pursuits may have granted him the intellectual freedom to think beyond the accepted scientific wisdom of his time. The practice of alchemy, which often involved experimentation with dangerous and unpredictable substances, may have honed Newton's keen observational skills and fostered his intuitive understanding of the behavior of matter and energy. In this sense, his secret obsession could have served as a springboard for revolutionary insights that pushed the boundaries of contemporary knowledge and laid the foundations for modern science. While some may dismiss this notion as mere speculation, it is undeniable that the enigmatic world of alchemy had a profound impact on Newton's life, both personally and professionally. In the end, the question of whether Newton's genius was sparked by his secret obsession remains a captivating and controversial topic, inviting us to reevaluate our understanding of the man who forever changed the course of human history. Through our exploration of Newton's incredible journey, we've gained a deeper appreciation for his tireless pursuit of knowledge and his unwavering dedication to uncovering the mysteries of the universe. Born into humble beginnings, he rose to become one of the most celebrated and influential figures in the history of science, forever altering the way we understand the world around us. His discoveries in mathematics, physics, and optics laid the groundwork for future generations of scientists and thinkers, inspiring countless innovations and advancements in multiple fields. Yet, beneath the surface of this extraordinary man, there was a secret passion that consumed him and drove him to explore the hidden realms of the unknown, the ancient and enigmatic practice of alchemy. Long considered a heretical and dangerous pursuit, Newton's obsession with alchemy revealed a side of him that defied the conventional image of a rational and methodical scientist, and instead, painted a portrait of a deeply spiritual and mystical thinker. By delving into the murky, forbidden world of alchemy, Newton sought to transcend the limitations of his time and unlock the secrets of the cosmos, ultimately shaping his worldview and guiding his groundbreaking scientific endeavors. It is this fascinating duality, the interplay between the rational and the mystical, that defines the enigma of Isaac Newton, providing us with a captivating glimpse into the mind of a man who dared to venture beyond the boundaries of the known and the accepted. Unveiling the hidden aspects of Newton's life not only adds depth to our understanding of the man himself, but also sheds light on the complex interplay between science and spirituality during his time. By examining his secret passions, we gain insight into the driving forces behind his unparalleled intellect and creativity, and how his unorthodox pursuits may have contributed to his groundbreaking discoveries. Newton's clandestine foray into alchemy and esoteric beliefs allows us to see him as a multifaceted figure, transcending the stereotype of the detached, purely rational scientist that is often painted in history books. Furthermore, acknowledging Newton's secret life reminds us that even the greatest and most revered minds can harbor unconventional interests and beliefs, challenging our preconceived notions of what it takes to be a genius. Embracing the enigmatic aspects of Newton's life also encourages us to question the arbitrary boundaries that have been imposed between science and mysticism, fostering a more open and inclusive approach to the pursuit of knowledge. In the end, knowing Newton's secret life matters because it humanizes him, allowing us to appreciate the full spectrum of his intellect and curiosity, and inspiring us to delve into our own passions, no matter how unconventional or misunderstood they may seem to others. Newton's groundbreaking work paved the way for the birth of modern physics, an interdisciplinary field that has allowed us to explore and understand the cosmos in ways that were unimaginable during his time. His development of calculus provided a mathematical framework for understanding complex phenomena, from planetary motion to fluid dynamics, revolutionizing the way we perceive and model our world. Newton's laws of motion and universal gravitation established the fundamental principles governing the behavior of objects on Earth and in space, paving the way for advancements in space exploration and our understanding of the universe. In the realm of optics, Newton's discoveries about the nature of light and his invention of the reflecting telescope opened our eyes to the intricate beauty of the microscopic world and the vast expanse of the cosmos, inspiring generations of astronomers and natural philosophers. Moreover, Newton's secret life of alchemy and esoteric studies possibly fueled his curiosity and innovative thinking, pushing the boundaries of our understanding and challenging established norms in both science and philosophy. As a result of Newton's enduring legacy, countless scientists, scholars, and thinkers have built upon his foundation, expanding our knowledge and appreciation of the universe, as well as inspiring new advancements in technology, medicine, and countless other fields.